Problem 6-51. Use the algebraic strategies you developed in today's lesson to solve the system of equations at right. Be sure to check your solution. So we've got the system over here that's given to us. Notice we have 3 equations because we're dealing with 3 different variables. So what we're going to do here is we want to solve the system to figure out what our values of x, y, and z are. Trying to find out what our intersection is going to be with this system. So as we look at the 3 here, remember the first thing we want to do here is find a way to eliminate one of the variables. In order to do that, I'm going to first of all just label my equations A, B, and C, just so I can use those to refer to the different equations. Might make it a little bit easier for you to follow along with what I'm doing, but also it helps me to sort my work a little bit. So the first thing I'm going to do here is, as I look at these, to me, I see that this one has a positive y and this one has a negative y, which sets up great for elimination right off the bat. So my first pair of equations I'm going to use here is A and B. I'm going to set up 2x plus y minus 3z, and that equals negative 12, and I'm going to use the equation 5x minus y plus z equals 11. Now, because this one's already set up very well to use elimination, I'm going to go ahead and do it here. I've got my positive y and my negative y here, which is going to cause the elimination when I'm adding these together. All I'm doing is taking each like term and combining it with the one from the other equations. So I end up with 2x plus 5x is going to be 7x. My y plus my negative y is going to give me 0, so that's been eliminated. Negative 3z plus z is going to give me a negative 2z. And then negative 12 plus 11 gives me negative 1. So I now have a linear equation here with 2 unknown terms. Let's go ahead now and look at coming up with a second one. The key part of this here is because I eliminated y in my first pair, I'm going to have to eliminate y in my second pair. So you can use whichever equations you want to use. I like the fact that this one's already got the negative, my b has a negative, and my c has a positive y. So I'm going to look at using b and c for my second pair. So I'm going to say here, I've got x plus 3y minus 2z equals negative 13. And I'm going to use my 5x minus y plus z equals 11. So now, if I would want to do elimination here, I have to look at it. If I added x and 5x, I would get 6x. If I added 3y and negative y, I get 2y. And if I added negative 2z and positive z, I get negative z. The way things are set up, this is not ready for elimination. I need to eliminate my y's, so I need to turn this negative y into a negative 3y. So to do that, make sure we're going to need to alter this equation, and we need to make sure we alter everything. So I need to have a negative 3y, so I'm going to multiply everything in my equation by a 3. So 3 times 5x is going to give me 15x. I'm rewriting this one over here. 3 times negative y gives me a negative 3y, and 3 times z is plus 3z. That should equal 3 times 11, which gives us 33. I'm going to go ahead and take my top equation. I'm just going to recopy it over here. Now there are more efficient ways of writing it there, or kind of doing a couple of these steps at the same time, but you want to do that when you're comfortable with it there and you're not making mistakes. So if you're new to this, go ahead and take some time, use some paper. It's not going to hurt you. So now I already have this equation over here. I'm going to end up with a second equation when I combine everything on this side. 15x and an x gives me 16x. 3y and a negative 3y is going to give us 0, so we've eliminated our y. So I'm going to go ahead and write my 16x here. Negative 2z and 3z is going to give me a positive z. And then negative 13 plus 33 is going to be 20. So here is my second equation. I'm going to take these two equations now and use them to figure out the values of x and z. So if I took this one here and I moved it over and said, all right, I'm going to do 7x plus, minus, getting a little ahead of myself there. So minus 2z equals negative 1, and then I've got 16x plus z equals 20. I'm going to want to now solve this. Well, I can do substitution if I wanted to subtract 16x, and then I could do 20 minus 16x for my z in my other equation, or I could continue on the elimination trend. And since that's my favorite, that's what I'm going to do. I'm going to take everything here. I'm going to multiply it by 2 so that I can eliminate my z's. So what we'll end up with here is 32x plus 2z equals 40. My top equation, I'm just going to bring it straight over. I've got 7x minus 2z. Ooh. Equals negative 1. As I do my elimination step here, my 2z and negative 2z eliminate each other, leaving us with 39x is equal to 39. In which case, x is going to have to equal 1. So now that I got x equals 1, I can take this, and I'm going to want to use one of these equations that I'm dealing with that has two variables to figure out what z is. I'll plug it into this one here. Let's say 16 times 1 plus z equals 20. Well, this is going to be 16 plus z equals 20, so I subtract 16 from each side, and I get z equals 4. Now we've got x is 1 and z is 4. Let's go ahead and let's just mark these. This is to find our z value here. We use the system here to find x. But now we're going to have to go all the way back up to the beginning here and use one of these equations from the top to figure out what our value of y is going to be. We know right now that x equals 1 and z equals 4. So let's plug those in here and figure out. And it doesn't matter which one you use. I'm going to use the top one. So I'm going to say 2 times 1 plus y minus 3 times 4 equals negative 12. So 2 plus y minus 12 equals negative 12. So we've got y minus 10 equals negative 12, in which case y ends up equaling negative 2. So what we're looking at in the next part, our answer, we're looking at the point 1, negative 2, 4. So this is x, y, z. Last part of it here, check it. Well, you've got two more equations that you could end up using. You could say, let's use 1, negative 2, 4, and plug it into one of our other equations. In fact, let's just do it up here. I think we could fit it in. Let's try our second equation. So we're going to say 5 times 1 minus negative 2 plus 4 equals 11. 5 times 1 is 5, minus negative 2 would be like plus 2, plus 4 equals 11, and you see when we add those together, we get 11 equals 11. We know we are correct. So there's a lot of work involved. I probably showed a little bit more than is absolutely necessary, but you know, sometimes it's better to be safe than sorry. Organizing your work is very important here, making sure you're writing large enough that you can read your own writing, and showing your steps. Like when I multiply each part of the equation by a number, I want to make sure I label that. So if I made a mistake, I can go back and find it. Answer, once again, the point 1, negative 2, 4. So these planes will all intersect at that exact point. This is problem 6-51. Thanks for listening. I hope this helped if you were having problems.